Hello world, what is going on? It's good to see you back here on the channel today, and I am excited because we are finally going to see a medium difficulty exercise which is called MaxCounter and is the exercise number 3 of Codility lesson number 4, where we'll see how to use a dictionary and a clever solution of storing some values to avoid taking the naive approach, which would be updating a lot of the elements of a list when they are not really necessary, or when it's not really necessary to update them to get the exercise done, because that would induce a lot of time and we will get a time limit exceeded if we do that. So without further ado, let's get into it. Okay, so as always, let's go back into the Codility lessons. This is Codility lesson 4, and we're going to check out MaxCounter. We're going to read it in Python, and it says, you're given n counters initially set to 0, and you have two possible operations on them. Increase x, counter x is increased by 1, and max counter, all counters are set to the maximum value of any counter. A non-empty array A of m integers is given. This array represents consecutive operations. If A at k, which is x, such that x is between 1 and n, then operation k is increase x. So this is telling us that for the counter x, if this x is between 1 and n, then we need to increase that counter by 1. And if x, which is A at k, equals n plus 1, then the operation k is to max out all the counters. So for example, given an integer n equals 5, an array A such that it contains 3, 4, 4, 6, 1, 4, 4, the values of the counter after each consecutive operation will be this right here. We'll see it on a second. So the goal is to calculate the value of every counter after all operations. Write a function that, given an integer n and a non-empty array A consisting of m integers, returns a sequence of integers representing the value of all of the counters after all of the operations are finished. So result array should be returned as an array of integers. So for the array given above, the function should return 32242 as explained, and write an efficient algorithm for the following assumptions. N and m are integers within the range 1 to 100,000, and each element of array A is an integer within the range 1 to m plus 1. So this is interesting because here we can see that if we have 100,000 operations, and each element of array equals max counter, the worst case scenario will be that we'll have to reset or max out all the counters 100,000 times. And if the array contains 100,000 elements, that is just 10 to the 5 2 times, which is 10 to the 10, which is just way too much operations. So we're going to need to find a more clever way to handle this. So let's look at the explanation of the exercise. Okay, so this is the array that we have on the example, and we're going to store the counters at 0, and we're just going to see what it should be doing. So at position number 1, which contains 3, we're going to increment the third counter by 1. When it is 4, counter number 4, then we increment again number 4, and when this is equal to n plus 1, we're going to max out all the counters to the maximum value that they had before. So before they had 2 as the max value, and when we have the number n plus 1, we equal all the counters to that value. Then we continue, increment counter number 1 by 1, then counter number 4 by 1, and counter number 4 by 1 again. So at the end we have the expected result, but as I said, on this operation right here, on maxing out all the counters, we can't just naively set each and one of the counters to this value, because if all of the operations are reset the counters and we have 100,000 of these, 100,000 square is a big number, it's actually 10 to the 10, and that's just not a feasible solution. So what we're going to do instead is we're going to have a dictionary where we are going to just store the increments after each max out. So on the first iteration, we're going to just add 1 to the number 3, the counter number 3. We're going to keep track of what is the maximum number on the counters so far. So for number 4, we add 1 because it doesn't exist. And number 4 again, it does exist, so we add 1. Right now the max so far is 2. And here comes what we talked about earlier, which is on the max out counters, we're going to store what was the previous value of the counters. In this case, it was 2 from number 4. So we are going to store that, and we are going to clean out our dictionary and continue with the execution. So for 1, we add 1. The max so far is 3 because we need to take into consideration that previously, because we maxed out the counters, it was 2. So we're always going to have to add this to keep an accurate count on the counters. So for number 4 is 1, and when we add again a number 4, it becomes 2, and this becomes 2. Now when we are finished, we are going to build our results array, where we are going to add all the items that are missing, all the keys that are missing, and we are going to add to each one of these this previous max so far, which is the count of the last time that we maxed out all the counters. So that was on operation 6, where we maxed out all the counters to 2. So what this is going to do is that we're going to add to each one of them the previous max so far, and we get the array that we expect without having to reassign each of these elements each time that we max out the counters, and that is going to save us a lot of time. So we're going to go ahead and look how to implement this into code. Okay, so we're back here at the exercise. Let's go ahead and start this test. Let's select Python here. Let's delete this. And the first thing that we're going to need to do is to declare our array. Sorry, not our array, our dictionary. So let's call this the counter dictionary, which will start at empty. We're going to define our max so far that starts at 0, and our previous max so far that will also start at 0. Then we're going to iterate over all the elements in A, and we're going to ask if this x is bigger than 1 and if x is less than or equal to n, in which case we're going to ask if x is in our dictionary. So this is counter dictionary. So if it is, we're going to say that counter dictionary at x, we're going to add 1 here, and we're going to define or update our max so far as the maximum between max so far and the previous max so far plus what's currently on our counter dictionary at x, of course. Now, if it's not on our dictionary, we are going to add it. So x on our dictionary will be 1, and we're going to update our max so far as well with the maximum between what we currently have and what we previously had plus 1. If you check, this is the same as this one because we are using the same here, the value at contradict. So here we are going to check the case where we have to max out all the counters. So the first thing that we have to do is counter dictionary will be empty because we don't want to reassign each position, and we're going to need to update the previous max so far to be what's currently on the max so far variable. Once this is finished, we need to build the object of our result. So for this, we're going to use a list comprehension. So we're going to iterate between 1 and n plus 1. And we're going to return the previous max so far plus we're going to add a conditional here where we are going to add what's on the dictionary. So counter dictionary at I if I exists in the counter dictionary, and else we're just going to add 0. And with that we should be able to build our result object. So let's return that and see if this is running correctly. It seems to be working fine, so let's go ahead and submit this task. And we got our results back with a correctness score of 100 and a task score of 100. Let me reload this to see if we can get the time complexity. And no, it seems that it won't load, so you'll have to trust me on that one. Okay, so that was the solution for the exercise max counter. We saw how to use a variable to store the previous maxed out counter value, so we don't have to reassign on each max out operation all of the counters, because that would take just a long time, especially on the worst case scenario, and that would give us a time limit exceeded. But by storing that value into a variable and at the end building the result object, we can save those operations and not do them and avoid getting a time limit exceeded, which is a pretty simple but yet clever solution. So that was everything for the video of today. If you like the content, please hit the like button, subscribe to the channel, and share with someone if you think it would be valuable for them. I'll see you on the next one. Bye!